Hey there, pause this video, attempt this question, and post your answers in the comments. So if possible, give this video a like. It helps out the algorithm so I can continue. So in this question, shows the ideas of the universe, which row applies to the steady state, and which one is actually... So we got, okay, firstly, there's two theories you need to know for the GCSE physics, IGCSE physics, GCSE physics. The steady state and the Big Bang theory. Now, what is the difference between the two theories? This diagram explains it. So the Big Bang theory is a really long thing, but basically the universe was the size of an apple or the size of an atom. They keep on debating about that. Infinite amount of temperature, we can't really quantify it. And from that spot, it expanded. And it didn't expand from a singular spot. It expanded from all different places. So if you look at the universe, actually, this image is really good for describing it. So this diagram is the cosmic microwave background radiation. Basically, it's the leftover heat from the Big Bang. So as the universe expanded, that radiation got stretched out and has turned into microwave background radiation, which is seen all over. Now, the red spots are slightly more hotter than the blue spots, but the temperature difference between them is like 0.5%. So the universe is pretty much evenly spread out, the distribution of the heat, the distribution of stars, and so forth. But if you focus on certain bits, obviously you're going to see more stars in certain places. But on a whole, as you're trying to look back, it looks pretty uniform. So there's no singular point where the heat actually originated from. So if the universe came from one place and expanded in that direction, okay, from that place, you'll notice a big heat signal from the middle, and it kind of gets colder, colder. But you don't, you see it everywhere. That's because the universe is expanding in all different directions, not just one direction. So this is the Big Bang theory, which we now believe. But before the Big Bang theory, there was something known as a steady state theory, and this diagram shows it. So you can see the steady state model. Now, the universe always existed. It had no beginning. It always existed, and it had a specific density. And that density is staying the same. So as we create more volume, we're creating more mass. So both theories believe that the universe is expanding, and because it's expanding, there's going to be something known as the redshift, which this diagram explains. So what is the redshift? The redshift is when an object moves away from us. So when an object moves away from us, you could think of the wavelength getting stretched out and it shifts towards the red, because the red spectrum has the longest wavelength when we compare it to blue. Blue is a shorter wavelength, hence why the sky is blue. That's a different story. And then the opposite of the redshift is the blue shift. When an object comes towards you, it gets kind of compressed about and it shifts towards the blue spectrum. So both theories, the Big Bang says the universe is expanding. The steady state theory says the universe is expanding. So both of them explain the redshift. But the cosmic microwave background radiation is only explained by the Big Bang theory, not by the steady state theory. So let's go back to the question. So the question wanted you to compare the two, okay? So both of them say that the universe is expanding, okay? They both say the universe is expanding, right? But which one only applies to the steady state theory? It doesn't believe that there's a beginning. So the steady state theory, yeah, is expanding, but it never had a beginning. The universe always existed, and it's just getting bigger. And as the volume gets bigger, the mass is getting bigger, and that's what's happening. That's the interesting thing about the Big Bang theory. If we go back to when the Big Bang theory existed, that is where time actually started to exist. State the name of the discovery that persuaded most scientists to prefer the Big Bang than the steady state. And that was the discovery of the cosmic microwave background radiation, which was discovered by mistake by people just pointing their antennas and they're seeing this static background. It used to be on television, this static, and they were like, what is this? They didn't know because they were pointing it in all different directions, because the cosmic microwave background radiation is in everywhere, and they figured out that it was cosmic microwave background radiation, which is leftover heat from the Big Bang. As it's getting stretched out, as the universe is getting bigger and bigger, that radiation is getting pulled out and pulled, stretched to the microwave radiation as we see it today. So subscribe to my channel. I post daily GCSE math and science videos. Take care and have a nice day. Bye-bye.